Let's discuss oil analysis for the food and beverage industries. This is a very interesting market segment that really can take advantage of on-site oil analysis. Let's look at the big picture. Why would an industry like this get involved in this type of monitoring? Well, the big picture is that there's a huge pressure on food and beverage industries to improve their operational excellence. And by that, they're looking to do a series of things. They want to obviously reduce the cost of manufacturing. They want to maintain regulatory compliance. They want to make sure that the product quality and their customer satisfaction remains at a high level. They want to maximize the productivity and reduce process variability. Almost all food and beverage industries have to have some sort of a voluntary plan for controlling this program, and it's known as their Hazards Analysis and Critical Control Points Plan, also known as HACCP. There are 6 major components to that. There's the Sanitary Standard Operating Procedures, Good Manufacturing Practices, Education and Training, Traceability and Recalls for their product and product identification, and preventive maintenance, predictive maintenance is a critical aspect of the 6-point plan. This is voluntary, but it is enforced by something known as the Food Safety Modernization Act in the US in 2011, and many other countries are following suit. So companies nowadays that violate this or have a product recall or some contamination in the system can be subject to enforcement penalties if they don't have some sort of a hazard control plan to deal with the issues. Now, within that, predictive maintenance, an important critical component to that is lubrication. Managing a lubrication program in a food and beverage industry is a critical hot button issue. Why? Because it's all about disruption avoidance. Keeping the equipment up and running, keeping the food production. There's a major concern about contamination control because of the issues we talked about earlier with traceability and food quality, and of course that impacts product quality. So as a result of that, oil lubricated equipment that are in food and beverage industries may require additional fluids and additional lubricants, particularly something known as food grade lubricants. What is food grade? Well, there are 3 major types of food grade, classified H1 to H3. There's a lesser one known as HT1. And these refer to the type of products that are certified by the National Sanitary Foundation, or which used to be USDA or DIN requirements. H1 is the most critical fluid, where an oil is placed in a piece of equipment where there may be incidental food contact. H2 really applies to general lubricants. H3 is complete food contact. Really, we don't see that on a condition monitoring program because that's actually applied to lubricants or applied to the food directly. It's edible oils. And of course, heat transfer is also similar to a H1, incidental contact. Incidental contact means up to about 10 ppm of the oil can get into the food system. So as a result of that, it must make sure that there is no contaminants or additives present that could be harmful or carcinogenic to human health. So as a result of that, oils are specifically formulated and then sent out for approval to meet those H1 standards. And many organizations in this industry require those for their application. An additional requirement for lubricant suppliers is to also include ISO 21469. That's a voluntary international standard, but not only does it cover the lubricant, but it covers everything associated with packaging and shipping and storage of the lubricant to the customer's location. So it's a more advanced voluntary standard that if a lubricant supplier is offering that, it means that they have very good control on their processes. Food grade and non-food grade oils are common in most of these food and beverage facilities, and they must be properly managed. They have to be separated. You have to have different types of supply equipment, different types of grease guns. They must be managed carefully. And so monitoring and proof of monitoring satisfies the requirement of the HACCP plan to say that you're in control of your process. So as a result of that, on-site analysis is essential. So, discussing on-site analysis for food and beverage equipment, let's talk about some general comments about the industry. What's interesting is that the actual equipment that's often used in these processing facilities on a per equipment basis, it actually tends to be much lower value than what we might see in other industries. And so as a result of that, it's a very low cost to replace. The actual equipment can be easily replaced by a quick replacement if it needs. They're rarely overhauled. Oil volumes are small in the compartments. Not as much volume as you would say in a mining industry or power generation, although food grade does give you a little bit of an extra premium. What's interesting is it's a very high cost of downtime. So even though you have a very small, cheap gearbox or conveyor belt bearing, the cost of downtime when that's a disruption issue is a big concern. The product quality risk is very high if there's contamination issues. So anytime we get oil into the system or contamination into the system as a result of the oil or the equipment not working well, that's a huge risk for the customer, the food and beverage supplier. And of course, and another issue is that there's additional required sanitary operating procedures such as pressure washdowns that are required on a regular basis, and that can impact oil contamination because water can slip by into the seals. So as a result of that, we have to be watching that and monitoring on a very frequent basis. Let's talk about the type of equipment that might be present in here. So the typical type of equipment we could classify as hydraulic systems, gears, grease systems, compressors, and chiller systems. These are the most common types of rotating equipment that you'll see in these type of facilities. In the case of hydraulic systems, they're used in a lot of different applications: bottle washers, packers, press fit packaging systems. The key tests we want to worry about are water, particle count, ferrous count, viscosity, metals and additives, tan and oxidation. Why? Well, we're always worried about making sure that's the right oil that's present. Obviously, if we have a food grade oil and we put the wrong oil in there, that's a high risk to the process. We're worried about contamination getting into the system. And wear is also a concern. If there's any wear at all, we need to know when to actually schedule the replacement of that system. In the case of gear systems, quite common in things like cutting tables and meat packing plants, conveyor belt drives, often used in breweries and systems like that, mixers in food applications, distillation vats for alcohol production. Water, ferrous density, viscosity, metals and additives and oxidation are also important. Not so much particle count. The ferrous takes over in those areas because many of these are very high viscosity oils. Seal integrity is, of course, a real concern, especially with things like cutting tables, whether you have a frequent washdown. You can have very high water present very, very rapidly there. Wear is a concern, but not in the traditional sense for overhaul, but we're worried about wear causing dimensional tolerance losses, which causes some looseness, and that can actually affect product quality. If we don't have the blade going at the right place, or we get metal shards going into the product, that's a big issue. And of course, oil type is a concern. In many of these systems, about 80% of the plants often will operate with grease bearings. You'll see them on bearings, conveyor belt drives, slide systems. We're worried about water, ferrous density, oxidation, and additives. Those, of course, indicate that is it the food grade product or not. We're worried about wear and washdown effects in those cases. And then, of course, the fourth utility in almost all these sites are compressors and chillers used for both cooling and, of course, air. Acid number, water content, viscosity, metals, ferrous density, TBN if it's an ammonia chiller are all of a concern. Our big worry there is those are actually the high value pieces of equipment in these sites. They're like the power utilities on the side. So we are worried about those, and any interruption of service can cause a major production loss. So as a result of that, we will always look at the Mini Lab series as a solution to try to address some of these issues. Why is it important? Well, several studies have shown that there is a major difference between the top performers in the food and beverage industry versus the laggards. Top performers met their KPIs of interest. They generally have up around an 80 or 90% overall equipment effectiveness, and generally they record themselves, or they put a response that they have about a 3.7 or 4 hour response time to any non-conforming issue on their plant site. And generally, they're extremely profitable with about a 9% operating margin to plan. Contrast that with the laggards in the industry who are trying to do better. 80% OOEE, 16 hours before they get chance to turn around systems, and a -1% operating plan. So you can see that bringing on-site analysis on board improves these metrics to get them into the top tier.